In this video, we're going to talk about firstly the concept of radians and where they come from, and then we're going to look at how we can convert from radians to degrees and then degrees back to radians. So consider in class at the moment, we're working with something called radians, but before that, we were working with a nice unit of measurement for angles, and we called them degrees. So consider if we had an angle here and we said this was angle of 30, what this would tell us is that from the relationship between the way in which these arrows are pointing, their relationship or the way in which they cut each other is an angle of 30 degrees. Similarly, if we had something like this, notice these two lines are perpendicular to one another or right angled, and therefore we'd say that they form an angle of 90 degrees. When we're working with radians, we're going to see something slightly different. So the same angle, rather than describing it as 30 degrees, we'd describe it as pi over 6 radians. And then for this one over here, we describe this one as, it's a right angle still, but we describe it as pi over 4 radians. Oh, not pi over 4, pi over 2 radians. So notice that on the left hand side here in blue, we're working with a unit where it seems tangible, it's easy to understand, and they're nice whole numbers. Whereas conversely over here, we've got these numbers. Firstly, they're not easy to understand, they're not rational, so they're irrational numbers. They'll go on forever if we try to evaluate them, and they just don't seem intuitive. But there is a reason why we only use radians when we start delving into the inner workings of trigonometry, and the reason being is that they allow us to do, or they allow us to integrate the angles outside with the other numbers. So we've been dealing with, say, sine, cosine, and tangent. The angle inside those functions, we can actually bring these out, but that comes later when we're doing, say, semester 2 of methods or spec or even university math. But we're going to start now because it's good practice to familiarize ourselves with these. So where does the concept of radians come from? Well, consider if we've got a beautiful circle, and I'm going to copy this circle because it's just so beautiful to look at. So there's one here and there's one going to be here. And at the very center of the circle, the very center right here, I'm going to draw a line that goes and touches the outside edge. And let's say that the length of this line, we'll say that the length of it is going to be, we'll call it C. Now the length from the inner point and the outer point, it's the length of C, and now I'm going to draw an arc around the circle. And the distance of this arc, I'm going to say is C, or the length of this arc is going to be C. And what we find is that using this measurement here, we'd form an angle inside here. Now we could express it in degrees, but we're defining what the purpose of radians is. And what we find is that for an arc that's drawn out that is equal to the length of its radius of the circle, we call that 1 radian. Now the next part to consider is, think about the circumference of the circle in general. Well, how big is this circumference of this circle? And we might recall back to our year 8 understanding and say the circumference of a circle is equal to 2 pi times c. So this c here, or this r in this case, which becomes 2 pi c. This tells us the full distance if we walked around this red edge. But what we're trying to define is a way in describing the angle inside the circle. And what we've said up here is that for an arc that is of the same length as the radius, we say it's 1 radian. Now, what about if we tried to measure the idea of this radian, or what if we ask ourselves how many radians are inside this actual circle? So if we go around full 60, how many, one way to look is how many times will this arc repeat itself around the circle? And we know that it's simply going to be the circumference of 2 pi c. But what about how many radians will we be able to fit? So the amount, or the circle itself, so we'll say radians per circle is equal to the circumference of the circle divided by the size of this arc. The size of this arc is just c. So then it becomes 2 pi c divided by c, and that simply equals 2 pi radians. So what we find is that we can normalize the angle inside the circle, or this angle that describes the rotation of the circle, in reference to the circumference of the circle. So we've effectively normalized this angle in here, the unit of measuring the angle, in relation to the length or the circumference of the outside of the circle. Now, if that doesn't make much sense, then not to worry, because eventually over time, you'll start building up an understanding where it will seem logical to use this irrational unit of measurement, and it simply just makes your life easier in the future when you're dealing with concepts such as calculus and the latter versions of trig. But going down, let's do some examples, and we'll say degrees to radians. Whoops. And in the top one, I told you that this is 30 degrees here, and we'll clean that up. That's 30 degrees. Then inside here, it's going to be pi on 6 radians. And the question is, why is that the case? Well, the way in which you can do it is we can say radians equals the degrees, and that's going to be multiplied by the radian. Actually, we'll go back. We'll say multiplied by pi radians divided by 180 degrees. So over here, in the red here, this is the general conversion to go from degrees to radians. But why is that the case? We'll consider, we could say simply degrees, and then we'll go times, and we could say 2 pi, and then put the 180 over here. Not the 180, sorry, the 360. So what we're effectively doing in this section here is we're finding the percentage of rotation around the circle in terms of degrees, and then over here it is the rotation of a circle, in terms of radians. So over here, this is the percentage that we've traveled around the full 360 degrees, and this is the rotation of the circle in radians. So a full rotation multiplied by the percentage of a part of a rotation. So if we want to go, say, 30, whoops, not that, radians equals 30 degrees, so this degrees here, multiplied by pi radians over 180 degrees, then we're effectively saying 30 into 18 times pi, and then this will simply taking or dividing both the top and the bottom by 3, we get 1 over 6 times pi, and then we find that our angle in terms of radians is pi over 6, so 30 degrees equals pi over 6. Now to go the opposite way, let's go 60 degrees, and then we'll leave this a mystery for now. And actually no, I said we'll go the opposite way, so we won't leave that a mystery. Let's pick another one. We'll go pi on 4 radians, and we want to find the degrees. Well, the way in which we do that, notice up here, we did degrees times pi over 180. We're going to do the reverse now. We're going to go degrees equals radians, and then it's going to be multiplied by 180 upstairs, and then downstairs we're going to put some pi. And notice that I've written the symbols for each, so the degrees upstairs with the little degree sign, and then the radians downstairs with the little c, which denotes radians. And then let's substitute in pi over 4 times 180 divided by pi, and I'm going to put in degrees, radians, and radians. So notice what's going to happen is, firstly, we're going to lose this pi component here. So pi divided by pi is going to cancel out and say goodbye to these radian symbols as well, which is nice. So 180 degrees. And then what's going to happen is, if we divide both upstairs, or if we divide upstairs by 4, what we'll find is that it's going to be 90 over 2, and then simply 45 degrees. So notice that the simple formula for converting to degrees in this case is you get your radians, your quantity in radians, multiply it by 180, and then divide it by pi.